Hi, I'm Jeff Wilson, and this is my instructional design project, a Canvas course developed to train faculty and students in the University of Redlands Art Department to use our Boss LS2440 laser cutter. This project was created using the Dick and Carey instructional design model, and in this presentation, I'll walk you through the full process, from needs analysis to formative evaluation. The university recently purchased a new laser cutter, the Boss LS2440, to replace an older Epilogue system. Right now, only a few faculty members know how to operate this new machine, and students have no formal training on how to use it effectively or safely. This Canvas-based course was designed to close that gap. The format is online asynchronous, but supports hands-on application in our physical studio in Ann Peppers Hall, room 222. The instructional goal is simple but powerful. Learners will be able to cut and etch various materials using the Boss LS2440 and Lightburn software. That includes everything from basic file setup to safe shutdown procedures. The learners are a mix of undergraduate and graduate students, along with faculty in the art department. Most of them are motivated and fairly tech-savvy. They know how to open files, use USB drives, and work with design software, but they've never worked with production hardware like a laser cutter. The learning environment includes the studio itself, which has some space limitations, and our LMS Canvas, which I use to deliver the content. All the equipment is provided by the university, including sheet materials, the laser cutter, and the computers with Lightburn installed. Accessibility-wise, the studio is reachable by elevator, but once inside it can get crowded, so the course emphasizes safe solo operation where possible. The main terminal objective is for learners to operate the Boss LS2440 from start to finish. That includes everything from opening a design in Lightburn to removing the finished product safely. Two key measurable objectives are calibrate the laser focus to ensure clean, accurate results, and import vector and raster files into Lightburn correctly scaled and positioned. Every object was checked for action verbs and observable performance. I wrote over 20 subordinate objectives to support the goal, covering everything from material handling to power settings. I created 5 instructional modules inside Canvas. These included orientation, machine components, Lightburn basics, startup and shutdown, and a final module on material loading, focus, job execution, and student-level maintenance. I originally planned 7, but it made more sense to consolidate the material, folding maintenance tasks into the last module where learners are already interacting directly with a machine. Each module includes clear learning objectives, visual previews, and hands-on assessments. I created a full storyboard to map out pacing, interactions, and media assets. This helped me keep the course consistent and manageable, especially since learners may be accessing it in short bursts. One key artifact is a drag-and-drop activity where learners label the machine's physical components. Because I couldn't use H5P in our Canvas instance, I built this activity as a custom React JavaScript web app. It allows students to drag labels to match machine parts and get immediate feedback. I used ChatGPT to help build the structure and logic of the app, and it helped speed up development and made it easier to debug across browsers. Other artifacts included a multiple choice entry skills test, a general laser safety pretest, and Lightburn configuration quizzes. For accessibility, I used alt text on all images, avoided color-only instructions, and ensured all non-original assets were properly attributed or covered under fair use. The instructional strategy combines elements from both Gagne's 9 events and constructivism. Each module starts with a clear objective and a visual preview of the task. I present new content using screenshots, video walkthroughs, and real-world examples, followed by guided practice, then independent assessment. The activities are scaffolded. Early modules focus on simple recognition and naming tasks, while later ones ask learners to synthesize multiple steps, like setting up a cut file and adjusting parameters based on material thickness. To maintain engagement, I used aspects of Keller's ARCS model. Attention, pulled through real-world project examples and tool demonstrations. Relevance, learners really want to know how to use this piece of equipment. They are motivated. Confidence was supported by clear instructions, simple interfaces, and plenty of feedback. Satisfaction is reinforced through successful practice and previewing real outputs. The psychomotor domain was especially important here. Learners need to physically operate the laser cutter. But cognitive skills like understanding raster versus vector, image resolution, and material safety were layered in to support informed decision-making. The course was designed with flexibility and diversity in mind. Instructions avoid idioms and assumed knowledge. I used neutral, inclusive visuals and gave learners the option to apply their skills in a way that makes sense for them, whether that's artistic expression, product design, or prototyping. By structuring assessments around performance rather than preference, I minimized cultural bias and supported learners with different creative goals. I conducted a one-on-one test with my wife. She's not a designer, which made her feedback especially useful. Her biggest critique was consistency. She noted that the module headers were filled with emojis and that some pages felt unstructured. She also suggested creating overview pages instead of dumping learners straight into full Canvas modules. I revised the layout, deleted most emojis, except for warnings, and created landing pages with concise module previews. I'll be doing small group and field evaluations next via email using the pre- and post tests already embedded in the course. This project gave me a much deeper appreciation for the Dick and Carey model. I've used ADDIE before, but what I liked about Dick and Carey was how it spelled out every single step. No guessing. It forced me to be intentional about every aspect of instruction, not just what to teach, but how, why, and how to assess it. One of the biggest takeaways was learning to work iteratively. I had to let go of perfection early on, focus on getting a working version in place, test it, and revise based on feedback. In that sense, the process mirrors a good design sprint more than a linear checklist. I also embrace tools outside traditional instructional design. For example, building the React JavaScript labeler gave me the freedom to design interactivity my LMS couldn't support. And I used ChatGPT as a thinking partner, not just to generate code, but to clarify logic, simplify interactions, and brainstorm UX improvements. This course is live in Canvas, but it's not finished. I'm sharing it with the instructional design team at Redlands this summer, and I will continue iterating based on their feedback. As someone with a background in graphic design, I'm used to the idea that a project is never done, it's just shipped. And I'll be refining this as technology evolves and new students come through the program.